Good morning, everyone. Myself, Dr. Krishna Chaitanya. Today, I'll be dealing a small topic, which is blood and its composition and also its functions. Okay. I'll be sharing a small PPT and I'll discussing about it. Fine. Our topic for today is composition of blood and its functions, right? Coming to blood. What is blood? Blood is a liquid connective tissue, right? As everyone knows, blood is a liquid connective tissue. It flows in the vessels in our body that flows through the heart. When heart constricts during systolic phase, what happens? The blood from the left ventricle moves through the aortic aorta, and from there it moves to the all the parts of our body, right? This blood, any idea what is the volume of blood? It depends, right? It's not equal. Like it's not like there is around 6 liters of blood in me, and that might vary from you. How is that gets calculated? The blood is somewhere around 7.7 to 8% of the body weight of an individual. Let's say, for example, if I'm an individual of 70 kgs, so 7% of 70 is roughly around 4.9. So approximately the volume of my blood would be around 5 liters. And what is the color of my blood? Color of the blood, as we know, let's say if we prick, what happens? The uh, the capillary bleed starts oozing out, right? The blood, you can see the color of it. So what is the color of the blood? The blood is usually red in color. The reason behind it is due to presence of oxyhemoglobin in the RBC, right? So what are the components of the blood? Let's say if an anticoagulated blood is allowed to stand in a narrow tube. I meant to say I'm taking a small tube, I'm adding some sort of anticoagulant, and then I'm adding my blood to the tube. So what happens? Upon settling, the blood gets separated, and the bottom part, which gets sedimented, is the cells. And the topmost one is nothing but our plasma, right? See, so the blood can be divided into plasma and cells. The plasma is somewhere around 55%, and the cells are around 45%, right? So in the cells, when I say cells, what kind of cells, what and all are present? We would be able to appreciate RBC, we would be able to appreciate WBC, and also the platelets. And coming to plasma, in plasma, as that is of 55%, so in plasma, around 91% of that 55% is completely water, and the remaining 9% is solids. In solids, what do you see? There is around, it's 9%, right? Among those, we would appreciate 1% of it is organic molecules, and the 8% of it is inorganic molecules. Coming to the inorganic molecules, what are those? Extracellularly, you will be able to appreciate sodium, calcium, chlorine, and bicarbonate. Whereas intracellularly, you will be able to see potassium, magnesium, copper, and other ions, right? And coming to 8% of the organic molecules, you'll be seeing plasma proteins, which is 7%, and non-proteinous nitrogenous substances would also be present, and also sugar, fat, and hormones and other enzymes as well, right? Here is what we will be able to see, a word known as hematocrit. What do you mean by hematocrit? Hematocrit is nothing but the percentage of the blood occupied by RBCs, right? The percentage of the blood which is occupied by RBCs is known as hematocrit. So how to test for hematocrit? If you want to test my hematocrit, what you should be doing is take the anticoagulated blood in a Wintrob's tube. Wintrob's tube is nothing but a small kind of test tube, which I'll be showing you in the image, and then proceed with centrifugation. Once centrifugation is done, what happens? The cells which are heavier, they get settled in the bottom, right? These cells which are getting settled down in the bottom plays an important role. And hematocrit is around 40 to 45% in males, whereas that is somewhere around 5 to 6% less in the females. if I have polycythemia, I meant to say polycythemia is nothing but increase in RBCs. In this condition, hematocrit also increases. Whereas in a patients of anemia, anemia is nothing but decrease in RBC, decrease in hemoglobin. In those particular patients also, what we'll be observing? We'll be seeing less hematocrit, right? Yeah, this is what the beautiful diagram. Here we can see what is this. The one over here, which I am able to appreciate, is the yeah, this one. This is your Wintrobe's tube, right? Wintrobe's tube. What is it? Wintrobe's tube after centrifugation. Once the centrifugation is done, see this top part which is present is nothing but your plasma. And in the bottom where you are seeing this red color, this is your packed RBC, which is nothing but hematocrit. And in between these, if you will be able to appreciate this white part, right? This is nothing but your buffy coat, which includes WBC as well as platelets, right? As we just discussed, what is buffy coat? Buffy coat consists of WBC and platelets. And coming to the plasma, which was the topmost layer, right? Here you'd be able to see this plasma, this whitish part over here. This is plasma. So what's happening? This plasma is lightish yellow in color. And what is plasma? That is nothing, in a simple terms, that is blood minus blood cells. And here, coming to here, the composition of the plasma is already discussed earlier, right? And which has organic, inorganic kinds of solutes and more, I mean, higher percentage of water is present in it. And what is serum? This plasma, if you take this plasma and if you're removing clotting factors from it, mainly the clotting factors number 1, 2, 5, and 8. So the rest of part, we call it as serum. And this serum has increased serotonin content. What is the reason behind it? Any idea, guys? The reason behind it is because of breakdown of platelets during clotting. Whenever clot occurs, what happens? The platelets gets broken down, and due to which the serotonin content will increase. And at last, we would be able to see the functions of the blood. What are the functions of the blood? That helps in respiratory function. What do you mean by respiratory function? What does it do? This blood, the RBCs present in the blood carries oxygen, right? The hemoglobin basically that is carrying oxygen from the lungs and that is giving to the tissues. At the same time, it is taking carbon dioxide from the tissues and giving back to the lungs so that the carbon dioxide can be exhaled out. Coming to nutritive function, how does the blood help in nutritive function? Blood, as soon as we eat the food, these nutrients, the macronutrients, gets digested and converted into micronutrients, and these micronutrients enter into the blood circulation, right? And from there, that gets applied to all the parts of our body. And coming to excretory function, I mean, the metabolic waste of our body and everything, what happens to them? The nitrogenous waste, such as our creatinine or urea. So what happens to all those? All those in the blood, they travel in the blood and reach kidneys. And in kidneys, what happens? They get excreted out, right? And coming to the part of immunity, as we all know, the blood, the WBCs, right? In blood, what we are having in cells, the WBC, which plays an important role in, I mean, providing immunity by fighting against the foreign organisms. Coagulation. How does it help in coagulation? As we all know, it has the clotting factors, with the help of which, and also the platelets, which helps in the formation of platelet plug. So in this way, this blood helps in coagulation as well, and homeostasis. That is nothing but milieu interior, maintaining the constant internal environment. This blood also plays an important role in maintaining pH, electrolyte, and water balance in the body. And coming to chemical communication, how does that do the chemical communication? That is by hormones, right? The hormones which are released from our, let's say, pituitary gland, how does they act on the effector organ, right? Let's say, I'm just giving a small example. If, let's say, follicular stimulating hormone, from where does we'll be getting follicular stimulating hormone? Initially, the hypothalamus, will be releasing gonadotropin releasing hormone. This releasing hormone acts on anterior pituitary, and that in turn produces FSH and LH. So this FSH and LH will travel all together from the pituitary gland in the blood and reaches the ovary, and in the ovary they acts, right? So as a part of chemical communications also, blood is helping out, and the blood also helps in regulation of body temperature. And finally, the plasma proteins. You all know that plasma proteins consist of albumin, the globulin, fibrinogen, and prothrombin. All these functions can also be included in the functions of the blood. Thank you, guys. Thank you.